All right, starting lesson 4.3, right triangle trigonometry. All right, it's time to get reacquainted with some properties that you learned back in geometry. Okay, so some right triangle properties. We have two different types of right triangles, a 45, 45, 90 and a 30, 60, 90. All right, now these two triangles have different relationships among the side lengths. All right, so here we have this 45, 45, 90. These two sides have the same length. Those are known as the legs that make up the right angle. Okay, and if we multiply either of those by square root of 2, we obtain the length of the hypotenuse. All right, so for example, if these were 5, then the hypotenuse would be 5 square root of 2. All right, going on to the 30, 60, 90. All right, so we have a 30-degree angle, and across from the 30-degree angle, you will always find your short leg. Across from the 60-degree angle, you will always find your long leg. And across from the 90-degree angle is your hypotenuse. Okay, so there's a particular relationship among the lengths of the sides of this triangle. If you take the short leg, you multiply it by square root of 3, you end up with the long leg. So if this is 5, then the long leg would be 5 square root of 3. Everything goes back to the short leg for 30, 60, 90. So then I take the short leg and I multiply it by 2, and that gives me the length of the hypotenuse. All right, it's easy as that. Get very familiar with these properties. You're going to use them very often. All right, methods for solving for a side of a right triangle given one or two sides. All right, you can apply the Pythagorean theorem if you have two sides. All right, a squared plus b squared equals c squared. All right, that always works. You can apply Pythagorean triples. Now, these work sometimes when you notice them. If you have a leg of length 3 and a leg of length 4, then that means the hypotenuse is 5. If you have a leg of length 3 and you have the hypotenuse 5, then the other leg would be 4. All right, and the same concept for a 5, 12, 13 triangle. All right, then you could apply the 45, 45, 90 and 30, 60, 90 properties. All right, and these work sometimes as well. All right, but Pythagorean theorem, that always works if you have two sides. All right, so we have example 1. Find the values of x and y. All right, this is 45 here. This is 90. The angles have to add up to 180, so this must be 45 degrees here. Now, these two side lengths are the same because the angles across from them are the same. So x is equal to 5. And since I'm working with the 45, 45, 90, I simply take the leg, I multiply it by the square root of 2, and I get the hypotenuse. All right, and then I'm done. All right, for part B, here I have a 30, 60, 90 triangle, okay, because once again they have to add up to 180. So across from the 30-degree angle is my short leg. I take that, I multiply it by the square root of 3, and I get my long leg. Simple as that. All right, and if I want to get the hypotenuse, once again I go back to the short leg, I multiply it by 2, and I get the hypotenuse. All right, so y is equal to 10. That's all there is to that. All right, and then here I have 3, I have 5, and then I have x. Well, I could use the Pythagorean theorem. That always works. But if you recognize this, it can make the problem much easier to do. One leg has length 3, the hypotenuse has length 5, so then the other leg must be length 4, just based off of the Pythagorean triple. If you know these, they can make life much easier at times. All right, that's all there is to that. Going on to the next idea. All right, trigonometric functions. We have sine, cosine, tangent, and there's 3 more. There's cosecant, secant, and cotangent. All right, so now there's an acronym to help remember trig ratios. So, COTOA. All right, we could remember it like that as well. All right, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. That covers these three here. Then the others are just the inverse, the reciprocal. All right, so just flipping it over, I have hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. Okay, notice that the ones starting with C are across from each other, so often students mix these two up. All right, be very careful with that. If you remember it like this, all right, this one starts with the S, this one starts with a C, they go together. This one starts with a C, this one starts with the S, they go together. All right, and then tangent, cotangent, that's usually the easy one to remember. All right, so if this is my angle theta, then across from it, that's my opposite side. The side that touches it, that's the adjacent side. And then across from the right angle, you always have your hypotenuse. All right, these never overlap. All right, supply concepts now. For example 2, find the exact values of the 6 trig functions of the angle theta shown in the figure. Always rationalize the denominator. Okay, so sine is opposite over hypotenuse. All right, I have 4 here, I have 4 here. Since these lengths are the same, these angles must be 45 degrees. And since it's a 45, 45, 90, I multiply by square root of 2 to get the hypotenuse. All right, now I could figure out all of my functions here. So I have opposite, which is 4, over hypotenuse, which is 4 square root of 2. All right, this simplifies. I need to rationalize the denominator. So I get 4 square root of 2 over 8, which gives me square root of 2 over 2. All right, sorry, getting a little scrunched here. All right, then I have cosine, which is adjacent over hypotenuse. And that's the same thing that we had before, so no need in doing the same work over again. All right, then tangent is opposite over adjacent, which is just 1. Then I have cosecant, which is hypotenuse over opposite. Cancels out, I get square root of 2. All right, that's for cosecant. Then I have secant, which is hypotenuse over adjacent. Same deal as before. That's secant theta. And I have cotangent, which is adjacent over opposite. That's just 1. Alrighty, going on to the next example. All right, sketch a right triangle corresponding to the trig function of the acute angle theta. Label all the side lengths. Okay, so we have theta equals 5 over 7. All right, so I'm going to have to draw a triangle, just a general sketch. That's my theta. Your theta is never your right angle, okay? It's always one of these two angles. All right, and across from it is my opposite. Then I have my adjacent here, which is 5, because this is adjacent over hypotenuse. That's 7. Okay, how do I figure out the opposite side? Because it says to label all the lengths. All right, well, I'm going to use the Pythagorean theorem. I'll call this x. So I have 5 squared plus x squared equals 7 squared. Pretty easy stuff to do. So I got 2 times 12, 2 times 6, 2 times 3. I have a pair, so I could pull out 2. And what's left inside is 2 times 3, 6. All right, so there we go. I've labeled the triangle. All right, that's all there is to it. Let's go on to the next example. Okay, this one table is going to summarize everything that we've done thus far in the chapter. Okay, so I have cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. Cosecant is hypotenuse over opposite. Sine is opposite over hypotenuse. Tangent is opposite over adjacent. Okay, so I have 45 degrees in radians. That's pi over 4. All right, just review the material from the previous lesson if you forgot how to convert from one to the other. All right, then it says function value. Okay, well, I'm going to have to sketch a triangle here. and I have 45 degrees for my theta, or one of my angles. That's my theta here. All right, so I'm going to make up side lengths for the legs. I'm just going to call them both 1. All right, so what would be the length of the hypotenuse then? It would be 1 square root of 2. All right, and coming up with the function value, it's adjacent over hypotenuse, so that's adjacent. There's hypotenuse, that's opposite, so it's 1 over 1 square root of 2. Multiply top and bottom by square root of 2. I get square root of 2 over 2. Alrighty. So I could have just as well chose 100 here, and 100 here, and I would have 100 square root of 2. It would still simplify to the same function value. All right, here I have pi over 4 radians. That's going to be 45 degrees. And I'm just going to go back to the same triangle I drew before because it's not going to look any different. So I'm going to use, let's see what I have here. Hypotenuse is 1 square root of 2 over adjacent, which is 1. So that's just square root of 2. All right, and then cosecant, I have square root of 2. All right, cosecant is hypotenuse over opposite. So I could rewrite this as 1. All right, and here, looking at the triangle, I have square root of 2 for my hypotenuse. I have 1 for my opposite. So that means it must be a 45, 45, 90. So that's 45 degrees, and that's pi over 4. All right, and for the next one, I have pi over 4, 45 degrees once again. And I have opposite over hypotenuse. So opposite is 1. Hypotenuse is square root of 2. So same deal as before. Multiply top and bottom. I have square root of 2 over 2. All right. And now I have another one. I got square root of 3. All right. If you have square root of 3 in your function value, that means you're working with a 30, 60, 90. All right. So I'm going to have a 30, 60, 90. Okay, and tangent is opposite over adjacent. So the opposite is going to be square root of 3, and the adjacent is 3. All right. What's going on here? Now, this confuses a lot of students because here you have the short side, and that's square root of 3 in this case. But the long side is just 3. Now, how does that happen? Well, if I multiply the short side by square root of 3, that should give me the long side. Well, what's square root of 3 times square root of 3? 3. All right, so that just verifies that what we're doing is correct. All right, now this is the angle I'm working with because that's what gives me this ratio. So this is going to be 30 degrees, and 30 degrees in radians is pi over 6. All right, going on to the next example. All right, use the given function values and trig identities, including the cofunction identities, to find the indicated trigonometric functions. All right, this is actually quite an easy problem. I'm going to create a triangle using that information. So I have 30 degrees, opposite is 1, hypotenuse is 2. That's 60 degrees. And I multiply the short leg by square root of 3, that gives me the long leg. Then I have tangent of 30 degrees. All right, and then I have opposite, which is square root of 3. And then I have 3 here. So I multiply the short leg by 2, and I get the hypotenuse. All right, now for solving these functions, you could use either triangle. All right, you're still going to get the same result. So for cosecant, I have 30 degrees. So that's going to be hypotenuse over opposite. That's going to be 2 over 1. That's just 2. That was easy. Next one, I have cotangent of 60. All right, since I'm working with a 60-degree angle, I'm going to use that angle, and cotangent is adjacent over opposite. Okay, pay close attention here. Adjacent in this case is 1, and the opposite in this case is square root of 3. All right, so I'm going to have square root of 3 over 1, which is just oops, I wrote that out wrong. Like I just said, adjacent is 1. You got square root of 3 on the bottom. Okay, so we rationalize the denominator, and we get square root of 3 over 3. All right, for the next one, you have cosine of 30. So opposite, let's see, we have adjacent over hypotenuse. Adjacent in this case is square root of 3. Hypotenuse is 1. Okay, no, hypotenuse is 2. Yeah, there we go. We're done now. Okay. And then we have cotangent of 30. Okay, I'm just going to use the second triangle. You don't have to. You're still going to get the same result. So I have adjacent over opposite. And it's going to be adjacent is 3. And then I have opposite, which is square root of 3. So I end up with, let's see, square root of 3 times square root of 3 top and bottom. I get 3 square root of 3 over 3. Cancels out. I just get square root of 3. All right, done with that. All right, example 6, last example of the lesson. All right, same deal as before. I have to use information, construct a triangle. So this is 5 over 1. All right, using a different symbol here. Don't freak out. It's the same thing as theta. All right, no different. All right, it's just a different symbol for indicating a angle measure. All right, so here I have my beta. And I have opposite over adjacent for tangent, so opposite is 5, adjacent is 1. Okay, now if I want to figure out the hypotenuse, I have to use the Pythagorean theorem. So I get 26 equals x squared, square root, x equals square root of 26. Alrighty, and let's see, we got cotangent now, which is adjacent over opposite. So what's adjacent in this case? Well, it's 1. And what's opposite? It's 5, 1/5. That's all we have to do. Cosine of beta. All right, cosine is adjacent over hypotenuse. So we have 1 over square root of 26. Multiply square root of 26, top and bottom. So I get square root of 26 over 26. Nothing else we could do there. All right, now for this big problem, which isn't that big at all once you understand what's going on here. What's with the 90 minus beta? What's that all about? Okay, well, what do these two angles add up to? Well, this one's 90 here. So the other two must add up to 90 because they all need to add up to 180 together. So if I want to figure out this angle here, I'm simply going to take 90 and subtract beta. So that's the angle we're talking about here. So now I have tangent, which is opposite over adjacent. So now I'm looking for the length opposite to this angle here. Well, opposite to that is 1. And what's the side adjacent to this angle here? It's going to be 5. All right, so then we're done. Pretty easy problem once you understand what's going on. And then we have cosecant, which is hypotenuse over opposite. All right, hypotenuse is square root of 26, and the opposite is 5. Nothing we have to do there. We are done. If you have any questions, please make sure to ask. Begin the assignment at the bottom of the webpage.